Hello friends, this video on P block element part 36 is brought to you by examfear.com. No more fear from exam. The next important compound is oxoacids. See, oxoacids is what? Which will have oxygen, hydrogen and sulfur. These are my oxoacids of sulfur. There are so many oxoacids of sulfur. H2SO3, H2SO4, sulfurous acid, sulfuric acid, H2S2O5, then you have H2S2O7, H2SO5, H2S2O5. There's so many, actually they're same actually. There's so many oxoacids of sulfur. Some of them are unstable, some of them are stable. So let's take some of them. For example, we'll take sulfurous acid, pretty popular one. So that structure will be like this. That is H2SO3. This is sulfurous acid. The next important is sulfuric acid. Sulfuric acid, this is correct, H2SO3, correct. The next is sulfuric acid. Sulfuric acid, you have OH here, I have OH here, double bond or H2SO4. Yes, this is my H2SO4. This is sulfuric acid. Let's take one more important compound, H2S2O8 peroxy disulfuric acid. So that is, let me draw the structure of this. This is the structure. This is H2S2O8, 2H, 2 sulfur, 4, 8 oxygen. This is peroxo disulfuric acid. One more I can take is oleum. That is also pretty useful. That is called pyrosulfuric acid. H2S2O7, this one. So this is the structure of this. Okay, this is called pyrosulfuric acid or also called oleum. That is H2S2O7. Now let's understand preparation of sulfuric acid, the king of all acid. This is the most important chemical and this is manufactured by a process called contact process. This is my sulfuric acid, H2SO4, very important chemical, and it involves 3 steps. The first step is my burning of sulfur or the sulfide ore in air to generate sulfur dioxide. So I have sulfur, you burn this, you get sulfur dioxide. That is the first step. The second step is the most important step, that is nothing but conversion of sulfur dioxide to sulfur trioxide. And this is done by reacting my sulfur dioxide again with oxygen in the presence of some catalyst. B2O5 is the catalyst used typically. And this is the most important step, and this happens at a temperature of 450 degrees Celsius and 2 atmospheric pressure. That is the third step, most critical step. And the fourth one is the adsorption of SO3 in H2SO4. So you have SO3 from this reaction, you adsorb this in H2SO4 sulfuric acid to give oleum. We just discussed the oleum structure, H2S2O7. This is my oleum. So once it is adsorbed, you get H2S2O7. Then, in fact, you can make it fourth step also. This H2S2O7, when again it react with water, or when you dilute with this water, you get sulfuric acid. Typically, these two happens in one step. So we call that 3 step. 1, 2, and these 2 is 1, 3. This is the second step, is the most critical step for this. This is the key step. And note that this is an exothermic reaction. Delta H is minus 196.6 kilojoule per mole. This step is exothermic. It gives out energy. Also, if you notice, there is a decrease in the volume. You see, there are 1, 2 molecules, there is 1 molecule. So this delta H is negative with exothermic process, also decrease in volume. Thus, since it is an exothermic process, that means to favor this step, second step, that is the most critical step, to favor my second step, we need what? We need low temperature and high pressure. Why low temperature? Because this reaction is exothermic, it gives out energy, so we need low temperature. Why high pressure? Because there is a decrease in the volume, so you increase the pressure, the reaction will move in the forward direction as per Le Chatelier principle. Okay, as per Le Chatelier, it will go in the forward direction if you keep the temperature low and increase the pressure. But the temperature should not be very low. If it is very low, the reaction may not occur. So for that, the temperature chosen is 450 degrees Celsius or my 720 Kelvin almost. This is the temperature the chemist came out with after so many reactions. So this is the temperature that is used to convert SO2 to SO3. Most critical step. Once you have SO3, see, sulfur to sulfur reaction with oxygen gets sulfur oxide. Pretty easy step. Sulfur dioxide to sulfur trioxide. This is the critical step. You need catalyst and the optimum temperature. And why this temperature? Because it is exothermic process and the volume decrease. So high pressure will favor this reaction. So for favoring this reaction, we use low temperature and high pressure, temperature of 450 degrees Celsius and a pressure of 2 atmospheric pressure. And then we get one SO3 that is adsorbed in sulfuric acid to produce oleum, and this oleum is again dissolved in water to give sulfuric acid, and the sulfuric acid we get is almost 96 to 98% pure in this. So if you see, this is the step. I have my sulfur here, this sulfur, and this is oxygen. These two reacts, right, to form SO2. Okay, and then we capture all the dust. Okay, and then we have this reaction and we get SO3, and then this SO3 react with sulfuric acid, sorry, with this SO2 actually now I convert to SO3 here using catalyst V2O5. This is the most critical step, this one. And once we have SO3, sulfur trioxide, you get oleum, right? You get oleum, and then with this oleum, actually, you get this here, this oleum here, right? This oleum you can actually react with water to form sulfuric acid. Okay? And please note, the second step again is a very critical step. It's a reversible process actually. And that's why we are using all this low temperature and high pressure to favor this reaction in the forward direction as per Le Chatelier's principle. So for this we use catalyst V2O5, we use optimum temperature and optimum pressure. And the catalyst need not be V2O5. V2O5 is my divanadium pentoxide. We can also use platinized silica gel or platinized asbestos. Any of these can be used. Again, as I told once again, as per the Le Chatelier principle, we should use low temperature, but at a very low temperature, the reaction will be very slow. The sulfur trioxide yield is very low, right? If the pressure is very high, if they use very high pressure, we use only 2 atmospheric pressure if you see, but the Le Chatelier principle expects us to use high pressure. Why we are using only 2 atmospheric pressure? Because the pressure is very high. What will happen is this sulfur dioxide will attack the materials of the plant. This materials of the plant will get corroded by the sulfur dioxide. So we are maintaining only 2 atmospheric pressure and only 450 degrees Celsius temperature. We are not maintaining a very high temperature, not very high atmospheric pressure. Okay, but we use excess of oxygen. This also we use actually. We use excess oxygen. From here, if you see, we give excess of oxygen. Here also, if you see, this one, we give excess of oxygen. Not here. Here we pass excess oxygen. Okay. Let's see the whole step once again. So I have my sulfur initial here. This is burnt in the presence of air. This you burn, and actually this is sulfur burner. Here you burn the sulfur and you get sulfur dioxide gas. The sulfur dioxide gas which is here is impure. This is an impure sulfur dioxide gas, right? Now let me change the color first. So let me start once again. The sulfur and the oxygen, you burn the sulfur in this sulfur burner chamber and you burn the sulfur. So what you get is sulfur dioxide, and this is impure sulfur dioxide. This impure sulfur dioxide, which have a lot of impurities, it is passed through this dust precipitator. So this dust precipitator, what it will do is it will collect all the heavy dust particle. So all the heavy dust particle will trap and you will get little pure sulfur dioxide. Heavy dust particle is trapped here. So you can get SO2. It is free of heavy dust particles, but it will still have some impurities. To do this, we will wash this sulfur dioxide. To wash this sulfur dioxide, we use the water spray. And we use a cooling tower because we want to wash this at a lower temperature so that the reaction doesn't take place. Because sulfur dioxide is soluble in water, right? Sulfur dioxide plus H2O will give you H2SO3. So we don't want this reaction to take place. So we cool the temperature and we wash the sulfur dioxide. And here you get is wet sulfur dioxide, which will have very few impurities. It will have some impurities, but most of the impurities is gone. Now wet sulfur dioxide we can't use, we have to make it dry, right? To dry the sulfur dioxide will use sulfuric acid itself. Sulfuric acid we have seen is a dehydrating agent. It sucks all water molecules. So we'll pass this dry or wet sulfur dioxide through this chamber which has nothing but concentrated sulfuric acid. With this you'll get back the wet waste acid here, but the sulfur dioxide gas will be dry. Okay, now this sulfur dioxide gas will have some more impurities like arsenic oxides. So these arsenic impurities are purified here using this arsenic purifier, and this arsenic purifier has gelatinous hydrated ferric oxide. So this gelatinous hydrated ferric oxide actually helps in removing all the arsenic impurities from sulfur dioxide. So here we got pure sulfur dioxide after this. Okay, we got pure sulfur dioxide. Now since the reaction, second reaction, this is where we are. This is where we are. Now since we need this 450 degrees Celsius temperature, so we heat this SO2. So here also we get SO2 at 450 degrees Celsius. So we use this catalyst V2O5. Now you get SO3 here. So once you have SO3 here, this sulfur trioxide is absorbed in sulfuric acid to get oleum. Now once we have the oleum, we can prepare sulfuric acid based on, we can make desired concentrated sulfuric acid. Because we have oleum, we have to just mix this with water and you will get sulfuric acid. Okay, pretty easy. Sulfur burns in oxygen to form sulfur dioxide. This is little impure. We use this dust precipitator to remove all the heavy particles. Wash this sulfur dioxide in water. It is wet. We want the dry sulfur dioxide. We use sulfuric acid to suck all the water from the sulfur dioxide. We get the dry sulfur dioxide. Still it has arsenic impurities, so we use arsenic purifiers to get this pure sulfur dioxide. Here we have got the pure sulfur dioxide. We heat this. Till now we are in the first step only. We heat this to 450 degrees Celsius. 450 degrees Celsius, and then The second step start. In the second step, this heated sulfur dioxide at 450 degrees Celsius reacts with or is in contact with V2O5. Always there is oxygen here. If you see, oxygen is always along with it. So it forms SO3. Once sulfur trioxide is formed, it is adsorbed in the sulfuric acid to form oleum. Once we have oleum, we can form sulfuric acid of desired concentration easily. This is the process. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.